Hi, I'm Murugaveni. I'm going to teach about consumer electronics and troubleshooting. What is the very first topic is about microphone and types. In this, we are going to see about what is microphone, what are the characteristics of microphones, carbon microphones, crystal microphone, dynamic microphones, capacitor, electrolyte, and gun microphones, wireless and dual unit microphones, headphones, and headsets and its type, the types of headphones, hearing impairment, and hearing aids. These are the topics we are going to cover in this topic. So first we'll see what is a microphone. It's a microphone, it is a transducer. We know the definition of a transducer. Transducer is a device which converts one form of energy into another form of energy. But in microphone, it is also a transducer that which converts the sound in a wave into wave which is comes in an air to an electrical waves, which converts the sound wave into an electrical wave of same frequency and shape. It has many uses in today's world, from medicine to musical recording. So it reacts to a pressure input by the use of diaphragm. What are the characteristics of microphones? So the characteristic of microphones says about what is the output level, what is the frequency response, output impedance, and directivity. These are the important characteristics of a microphone. So first we'll see about what is the output level. The output level of a microphone which governs the sound that must be available for the use with a microphone. So it governs the amount of amplification what we are going to do with the sound energy. It is usually given in decibels, preceded by a minus sign. Why the minus sign has been induced here? The minus sign means the output level is so many dB below the reference level. That is a level of 1 milliwatt for a specified sound pressure. That is only the minus sign is indicated in the output. The unit of sound pressure used for rating the microphones is referred to as a bar. Speech provides a sound pressure between zero point 0.4 and 15 bars. For a music, the pressure ranges from zero point 0.5 bars to 1250 bars. Frequency response. It is a rating of fidelity of relative output voltage which results from the sound waves of different frequencies. It is a pilot of waves, it is a plot of waves of its output voltage versus input frequency. So after getting the readings, we'll plot between the output voltage and the input frequencies. So from that is called the how much frequency response we are going to receive from the microphone. A good microphones are relatively flat over the range. So if you take the flat will be increasing and it becomes flat, and then it becomes, so the flat range represents the how much the range of microphone is going to work here. This is the frequency response. So you can see that the output is represented in decibels and the frequency is represented in hertz. So there are different microphones, their characteristics have been plotted. Carbon microphone, crystal microphone, condenser microphone, moving coil microphone, and ribbon microphone. So this is the characteristic of a microphone. So output impedance. The output impedance, yeah, a micro, because we told that it converts the sound energy into an electrical energy. A microphone is like another component with the electrical inputs or outputs as a value of impedance. Any electrical inputs, if we take it, or the output, if we take it, it adds its, if I want to measure the electrical impedance values, naturally they have its own impedance. When a microphone is connected to an amplifier, a complete circuit is formed and electric current flows through whenever the sound causes the microphone to generate an electrical voltage. For most high quality microphones, the impedance will be very low. That is in the range of few ohms to 100 ohms. The capacitor and ceramic crystal microphones have a high impedance. So particularly ceramic type and the ceramic crystal microphones and capacitor microphones, they have a very high impedances. What is the directivity? Is that microphones do not respond equally to a sound reaching them from all the direction. The frequency response characteristics also vary depending upon the angle at which the sound reaches them. So that is, it says that it's a omnidirectional. So here, equally sensitive to a sound from all sides. It is very sensitive. It receives a signal from all directions. That is called, it is an omnidirectional. It picks up the sound from every direction. The sound is very general and unfocused. If you are trying to capture any sound from the particular subject or area, it is likely to be overwhelmed by the other noises. So omnidirectional microphones are good for ambient sound and group vocals. So this is cardiac microphones are very sensitive. They to the sound only in the specific direction. They are very sensitive to a particular direction. The most common type features a cardiac that is called whose you can see that the pattern of cardiac microphone, it is like a heart shape pattern that subject rejects the sound coming behind the microphones. Only directs straightforwardly, only it observes the direct sound energy. Behind this, I mean, other directions, if it, any energy or any sound energy comes, means it rejects all these things. So sound is picked up mostly from the front, but it is a lesser extent from the other side, emphasizing the sound from which the microphone is pointed. Cardiac microphones are very versatile microphone, ideal for gentle handheld applications. So next is going to be a hypercardiac microphone. They are exaggerated version of cardiac. It is another version of a cardiac microphone pattern. It is very directional and eliminates most of its sound from the side and the rear. So due to the long, thin design of an cardiac microphones, they are very often referred to as a shotgun or rifle mics. The shotgun or rifle mics are used as the cardiac microphone. These microphones can be very useful for isolating the what sound from the subject or the direction when there is a lot of ambient noise. If there is any ambient noises are available around the surrounding, it doesn't respond to those noises. Only it concentrates on the pure signals. So you can see that cardiac pattern. It is like a heart shape, one small pattern projecting outside. They can be also used to pick up the sound from the subject on a particular distance. So this is the cardiac microphones and hypercardiac microphones. So carbon microphones. Very first topic is carbon microphone. What is carbon microphone? The microphone, it was developed in early stages. That is around 1870s by the Englishman David Edward Hughes. It was the first reliable form of microphone, and it was widely used for many years before being supplanted by the other types that gave much higher levels of performance. It gives a very high level of performance. It was longer years it was being used. So what are the basics of carbon microphone? This is the structure of carbon microphone. It has a diaphragm. It has a carbon granules. You can see that there is a fixed electrodes are available, and the signal is applied to that one of the electrode. So basic concept behind the carbon microphone is that when a carbon granules are compressed, the resistance gets decreases, right? So this occurs because the granules comes into better contact with each other when they are being pushed together by the high pressure. So when a high pressure of sound energy hits the granules, they come in closer with each other. The distance get reduces. The carbon microphones comprises of carbon granules that are contained with a small what triad is covered with a in thin metal diaphragm. There is a thin metal diaphragm is available. So that diaphragm between the diaphragm and the fixed there is a small distance. In between that position only the carbon granules are being deposited. So a battery is required to cause a current to flow through the microphone. So battery is connected to the one of the electrode. When the sound waves strike the carbon microphone diaphragm, it vibrates, exerting a various pressure into the carbon. So what will happen when a high pressure of sound energy hits the wall of the carbon granules? These varying pressure levels are translated into a varying level of resistance because the distance get Varies due to that, what happens? The resistance gets varied. So which in turn vary the current which is passing through the microphone. The varying current can be passed through a transformer or a capacitor to enable it to be used in a telephone or by the form of some form of amplifier. So the advantages are it has a very high output, simple principle, and the construction is also very simple. It is very cheap and simple to manufacture. Disadvantages are very noisy. That is one of the main disadvantages. High background noise on the occasions would crack. So poor frequency response and requires a battery or other supply for operation. Applications where I can use it. Due to a limited frequency range, it is useful only in telephones. It is also sometimes used in portable radio communication cells. So next type is going to be a crystal microphone. Crystal microphone, this is the structure of a crystal microphone. You can have a closed case. Inside the case, we have a crystal. We have a diaphragm, and you can see that how the structure of the crystal microphone will be. So it is also it is very primarily used between the year of 1930 to 1960. At the time, there were very important to the home recording and small scaling paging market. For home recording and all, these crystal microphones were widely used. So it uses a thin strip of piezoelectric material attached to the diaphragm. Two sides of the crystal acquires the opposite change when the crystal is deflected by the diaphragm. So what happens? The charges are proportional to the amount of deformation and disappears when the stress of the crystal disappears. So this is the logic behind the crystal microphone. So early crystal microphones uses a rock-like salt because of its high output. We depend on the rock salt. So, but it was sensitive to the moisture and somewhat fragile. So later the microphones used a ceramic material. They replaced in rock salt and they use a ceramic material such as a barium titanate and zinconate. Advantages are they are very high, have high sensitivity, high frequency response or resonance frequency, high stability. These are some of the advantage of the crystal microphone. Disadvantages are the piezoelectric materials can produce only electrical response to the dynamic mechanics. One of the disadvantage of the piezoelectric materials, they cannot be used or for truly static measurements and all, we can't use it. Next is going to be dynamic microphones. This is the structure of a dynamic microphones. You can see that it consists of one magnet, a coil, and a diaphragm. These are the main equipments that we use in the design of a dynamic microphone. Sound waves vibrate the diaphragm that moves the coil, making an electromagnetic induction. This changes the electric charge which has been sent down to the wire, which is then converted into an audio using an analog to digital converter. This is the operation which takes in the dynamic microphone. Advantages are very robust, resistant to moisture, and very rarely expensive. Sound quality of the dynamic is generally not an accurate as a condenser, but they do not have a ability to withstand the more high sound pressure levels without any occurring distortion. This makes them very useful when recording a sound reasonably in a close or a loud. Applications. In practical terms, this means that the dynamic mics are very fine for a loud sound, such as drums and electric guitar. They are very good for medium level sounds at close range, such as vocals, and they can fall down badly when you try to record quiet or very distant sounds. This is a capacitor microphone. You can see also the logic is same only. The sound hits the wall and only the material what you are going to use it going to be different. This is the structure of a capacitor microphone. What do you have it? There is a front plate is there and basic plate is there. And you can see, sorry, basic means that is a back plate, front plate, back plate, and you have a battery is been connected, and you can see that the output signal has been given to one audio signal. So this is the structure. So working principle behind this condenser microphone has two plated diaphragms that act as one. One is one that can move, one which can act as a diaphragm. One which can move can act as a diaphragm, and one is fixed that act as an backplate. We call it a backplate. Backplate is constant, and which is facing. on the front side, that is going to be a movable one. That is a flexible one. So the sound energy when it hits the flexible what diaphragm, what will happen? It starts moving. It starts moving to and fro, depending on the pressure of sound what you're going to give it. This is a capacitor, or we can call it as a condenser, which is positively and negatively charged electrode, and an air space is lying between these two plates. Sound depresses the diaphragm, causing a change in the spacing between the front plate and the back plate. The charge between the diaphragm sends the signals down the wire to generate the sound. The important points are the diaphragms are very thin, which requires a less energy to vibrate them, which in turn makes the condenser mics very sensitive to the quiet sounds and are capable of capturing a high frequency. That is a specialty of condenser microphone. It requires a constant charge that is taken from the battery. There are two types of condensers. One is a small diaphragm and a large diaphragm. Small diaphragm mics are commonly used for vocals and live instruments and tends to be more accurate than the large diaphragms, have a wider frequency response. The small diaphragm mics are usually less expensive and can be used on the stage as a handset or to record instruments. Whereas the large mics commonly used to record vocals. So it is generally more deep toned microphone that tends to warm up the sound. The larger, more flexible diaphragm gives a richer, more detailed sound with a higher sensitivity. And also, it is generally preferable for primary announcing duties. So that is they for this purpose only they use in large diaphragms. So the main negative of the large diaphragms is that it is very expensive. Due to their expensive, the large diaphragm is looked upon luxury microphone in home studio. However, a large diaphragm microphones will generally or greatly improve the standard of all the recordings. Advantages are flat frequency response, ability to produce an instrument of or voice a lot more accurately than the dynamics. It is very high sensitive compared to the other microphones. More sensitive to the loud sound and can be expensive to repair the if it when it is gets broken. It is used to record vocals, guitars, cellos, cymbals, and any ambience. This is the electret microphone. Electret microphone. This is the structure of electret microphone. You can see that how it has been used. What are the things are available in the structure itself. You can able to see. There is a front cover, diaphragm. The material what you're going to use it going to be a polymer, and you can see that there are what back plate, front plate is there, back plate is there, and insulator, and you can see how the housing has been made, where the terminal and how it works with the polymer diaphragm. The internal architecture have been given. There is a capacitor with which is built in where it can build the charge by itself. When it's electrical battery has been connected, the capacitor two plates are there. They get charges they by themselves. How the charges are taking place, and you can see that the polished polarized electrode have been used, and you can see there is a metal plate electrode is also available. This is the structure of one. This is the how the microphone works. The figure B shows that. Construction. Electret microphone is a type of condenser microphone that comes with a permanent charge built in it. So it has a permanent charger is available which has been built inside the microphone itself. All microphones need a pair of charged plates. One is positive, another is negative in order to function and record the sound. The condenser microphone do not have a pre-charged but need an external voltage to charge the microphone diaphragm for the microphone to operate. Whereas the electrode microphones, it has a built-in charges available permanently. So instead of requiring an external voltage source to charge the diaphragm, electrode microphones uses a permanently charged mics as plastic element that is called electrode placed in parallel with the conductive metal plate. In the figure itself, I told that. So the applications are this. It is widely used to enable the communication recording as they are very expensive and offer a good performance. The key applications include telephones, smartphones, desktop computers, headset, hearing aids, lift controls, parking meters, surveillance equipment, and audio visual products. So this is a gun microphone. It is a type of directional microphone that has been designed to pick up the sound from the specific direction while rejecting the noise from the other direction. So you can see the structure. It is like a pen type. So it gets the same name from its long narrow shape, which similar to a barrel of shot gun. It is like a gun structure. It is used in situations where there is an important to capture the sound from the specific direction while minimizing the noise from the other direction. They are commonly used in film and television production as well as for recording lectures, interviews, and other types of speech. How strong the gun microphone is. You can see that they are actually a standard microphone element that is to be called as most probably we concentrate on the diaphragm at the end of a long hollow tube. That hollow tube called interference tube, such as it is uses a series of holes or the slots along its length so that it can reject the sound that is coming directly from its front of it. The microphone manufacturers spend huge amounts of time and money trying to perfect the design of their interference tube. So that hollow slots, what we are going to make it on the structure, it should be perfect enough so that it can capture the sound which is coming straightly, so that it has to reject the unwanted noises also. So because we are going to build in all those charging capacity, electric and all we have to build inside. So in order to do this manufacturing, it takes a lot of time to concentrate on the making of these slots. This is the next microphone called wireless microphone. How does it work? Wireless mics and send their output signals wirelessly via their built-in transmitters. The transmitter will encode the microphone's audio signal into the carrier signal and transmit them wirelessly in the receiver. That is called wireless microphone. Receiver will send decode the signal from for connected mic input construction. So it has three components we mainly concentrate on: microphone, transmitter, and receiver. So the microphone, just like a microphone, wireless microphone works as a transducer, changes the acoustic or mechanical wave sound energy into an electrical energy. The sound waves vibrate the microphone diaphragm. Vibration of this diaphragm will be converted into an electrical signal through their electromagnetic induction, that is called dynamic, and or variations in the capacitive capsule capacitance. The wireless microphone are typically in the style of handheld, lavalier, or headset. Transmitters. It works by transmitting the audio signal from the microphone through a radio waves. Transmitter takes a microphone output audio signal, converts into a radio signal, and broadcasts them through an antenna. This is the role of wireless transmitter. So wireless microphone system consists of three important types. One is handheld, plug-in, and belt-pack. Wireless microphone systems uses a frequency modulation, that is called FM, and need roughly around 200 kilohertz bandwidth. To have this bandwidth, the radio frequency bands utilized for sending the wireless microphone signals are typically either very high frequency or ultra high frequency. Very high frequency means it is 30 to 300 megahertz. Ultra high frequency means 300 megahertz to 3 gigahertz. So whereas when you come to the receiver, wireless, we know that receiver which takes the signal from the space and send it to the antenna. From the antenna, it receives a signal on the radio frequency of the microphone transmitter and converts it back to the audio signal. The receiver decodes all the desired audio signal and should be connected to a mic level input so that you can get the sound from that. So dual unit microphones. Dual unit microphones, it is available which make use of two units to secure a particular directional pattern. Dynamic unit is combined with a ribbon unit. The figure shows how the pattern will be. The figure shows the directional pattern which results when a bidirectional velocity unit and non-directional unit are combined. The resultant directivity pattern or cardiac-like pattern. So you can see that the most probably high frequency condenser microphone, that is 30, is matched with this remarkable directivity of MKH60. So it is a super cardiac microphone to enhance the stereo images. So headphones and headsets. What is headphone? Why we use a headphone? What is the use of the headsets? Headphone is a term used for the device that features two drivers which is connected by a headband and worn around the head It is also used as an umbrella term type. It is like an umbrella type that encompasses all the other arms. It is a one-way communication. Headsets are basically headphones with the microphones. It is an what type of how the microphone, different headphones and headsets have been used. So you can see that what important components that we used or that allows you to listen to the audio privately by converting an electrical signal into a sound signal. So the process are the audio signal, which is like a headphones, receives the electrical audio signal from the source like a phone, computer, or audio player through a wired connection or wireless technology that can be and Bluetooth also. A driver unit, we have it. The core component of the headphone is the driver unit, which converts the electrical signal into one sound, which is common. The common driver types, which are yes, dynamic drivers, balanced armature drivers, planar magnetic drivers. Dynamic drivers uses a magnet, voice coil, and diaphragm, whereas a balanced armature drivers, where it uses a compact and commonly used in ear monitors. Whereas a planar magnetic drivers provide a higher fidelity in premium headphones. So conversion of electrical energy into a sound energy, that is the concept of the headphones or any microphones we use it. So inside the driver, there is a magnet will be available, which creates a magnetic field. Voice coil, when the electrical signal passes through the voice coil, it generates an electromagnetic force. Whereas the diaphragm, the coil moves the attached diaphragm to and fro, that is back and forth, to create a vibration in the air, which generates the sound energy. Inside the driver, this happens. The sound waves, when you take it, the vibrating diaphragm produces the sound waves that mimic the original audio signal. These waves travel through the air and reaches your eardrums. What are the types of headphones we can use it? Over ear, on ear, in ear, open bag and closed bag. Over ear is called where it encloses the ears, offering a good sound vibrations. On ear is supraaural, rest on the ears and are lighter than over-ear headphones. In-ear is earbuds or IEMS, which is going to be your fit inside the ear canal and offering an portability. Open back and close back are refers to whether the headphones allow air and sound passes through the ear cups. Wireless headphones. Wireless headphones are Bluetooth or any radio frequencies to receive the audio signal. The process involves are encoding the audio signal into a digital format, transmitting wired through an radio waves. It transfers the signal in the form of radio waves, decoding it back to the sound at the headphones at the receiver side. Extra features are noise cancellation, microphones, and EQ settings. So it allows the to adjust the bass and treble and mids. This is the EQ settings. We do it in the what headphones. Types of headphones are supra-aural. This is the first traditional on-ear headphone wearing a style. This type has 1 to 2 inch speaker that rest against on your ear and delivers the sound down into an ear canal. So compact of headphones with adjustable band. You can see the picture headband. Soft palm pads are comfortable for listening, easier to carry around your daily activities, lightweight and compact, won't get the complete sound isolation and cancellation. Circumaural is a type of an headphone. You can see that how they are with the ear cups that can surround your ears. You may know them as over-ear headphones. Due to a larger driver size, it is often bulkier than the other some of the factors. Superb sound quality, you can get it. Not ideal to use them for physical activities or carry them on your daily commutes. Helps with a high noise cancellation. So intraaural is nothing but here you can see that how the structure of your earphone will be, which are more discreet, practical, and normally less expensive. They are very currently most popular in use. The position of this type of headphone, which is inserted into the external auditory pathway, favors the greater sensitivity levels since all the sound energy will is connected to the middle ear. Moving iron headphones. This is a structure of cross-sectional view of the moving head. You had as a diaphragm, ear cap, and you can have there is a magnet coil is available. Around that you have a case. It is a thin, flexible, soft iron diaphragm. Is supported by a casing clear, just clear of the tips of two soft iron pieces, pole pieces, which have been attached to a small permanent magnet. Magnetic attraction causes the diaphragm to be distinted slightly towards the pole tips. So, the incoming audio current passes through the coils around the pole pieces. In this presence of this audio signal, varying magnetic field is created by the current when it get interact with the permanent magnet, varying the pull on the diaphragm and causing it to move, or it causes a to and fro motions, or undergoes an vibration, thereby generating a corresponding sound wave. This is the working of an moving coil. And next one is going to be electrostatic headphones. Electrostatic drivers consist of a thin electrical charged diaphragm, typically coated membrane, suspended between two perforated metal plates, which act as an electrode. You can see the structure. So the electrical signal, when it is applied to an electrode, creating what will happen? It creates an electric field. So depending on the polarity of the diaphragm is drawn towards one of the plates. When air is focused through their perforations, combined with the continuously changing electrical signal driving the membrane, a sound wave is generated. Electrostatic headphones are usually more expensive than the moving coil ones. In addition, a special amplifier is required to amplify the signal to deflect the membrane, which is often requires an electrical potential in the range of 100 to 1000 volts. Hearing impairment and hearing aids. This is the structure of hearing inside what happens in the hearing aid. A person is said to have a hearing loss if they are not able to hear as well as someone with a normal hearing, meaning that hearing thresholds of 20 dB or better in both the ears. It can be mild or it can be moderate, or moderately severe or severe or profound, and can be affect one of the both ears. Right. The basic function of the hearing aid is to amplify the sound in such a way that it is made audible to the hearing aid user. Although many types of hearing aids are available, they all share a number of common features. What is microphone? How the structure will be? It converts the microphone, which converts the sound energy into an electrical energy. Electric microphones are most commonly used in this type. It is a special type of condenser microphone with a built-in low noise preamplifier. Electric microphone has more frequency response and low sensitivity to mechanical vibrations. Telecoil, it is transforms the vibrations into a magnetic variations in the magnetic field into an electrical signal, which can substitute the signal from the microphone. It is used in connections with the teleloop system, which are installed in the place of threads. In the places where we can, such as one of the example is going to be a theater, or churches, or the schools for the hearing impaired. Audio input. A sound can also be obtained by using an electrical input connection directly into the hearing aid. So amplifier, we know that the name amplifier says that it can amplify the signal. Also, the signal from the microphone or the telecoil are fed to the amplifier. The very low energy signal is transformed to a powerful electrical signal, which drives the hearing aid receiver. So next, what will happen at the receiver? It converts the electrical, whatever the signal which has been received from the antenna, it converts that amplified signal into an into a sound waves. The reverse action will take place. There are different types of receivers. We can have it both in size and performance. Generally, size determines sensitivity, maximum output of a receiver. Filters have been used for filtering the unwanted noises, which is used to reduce the amplification of low frequency, and high cut filters are used to reduce the amplifications of high frequency. So lower cut filters we have it, and higher cut filters will have it. They do their jobs. So output controls and AGC. So AGC is nothing but an automatic gain control. The amplification of hearing aid should be provided in such a way that which makes the amplified sound audible without being uncomfortably loud. If the sound wave is too loud at a certain frequency, the user may turn down the volume control to a point where gain at that frequency is insufficient.